it looks like the object is at least 5 kilometers in diameter and maybe more. And that means that it's at least 1,000 times more massive than the previous.
It happens the moment scientists expect calm. As 3I Atlas slips out from behind the sun, Gemini's cameras lock on, and something is wrong. The comet does not look burned out or fading. It looks altered. The once ruddy red coma is gone, replaced by a faint, unnatural green glow that wasn't there before. Not a blur, not noise, a clear signal. To astronomers watching live, it feels less like a color change and more like an activation, as if the object has crossed a threshold and begun doing something new. This shift is not cosmetic. Green light at this distance means specific gases are suddenly venting into space, gases that only appear when solar heat reaches fresh material buried below the surface. Frozen compounds are skipping liquid entirely, flashing straight from solid to gas. That tells scientists the sun is no longer just warming the outside. It is breaking into deeper layers, layers that have never been exposed before, and the response is uneven. Some regions stay quiet. Others flare alive. The comet is not reacting as one solid body, but like a patchwork of hidden chambers turning on at different times. That detail raises alarms. Astronomers expect comets to calm after perihelion, not escalate. Stabilization is the norm. Instead, 3I Atlas changes character after its closest pass, when most models predict the drama should be over. This timing feels wrong. It suggests delayed heating, trapped pockets, or volatile material only now waking up after billions of years in deep freeze. Scientists don't call it beautiful. They call it diagnostic because every green photon is a clue that something inside the comet is shifting, unlocking, or failing. And that is what sharpens the fear. If this is only the first layer responding, then the most reactive material may still be buried deeper. The glow Gemini captured could be the opening act, not the peak. Every telescope now pivots, every wavelength is cued, because once a comet starts changing this fast, the next signal rarely announces itself in advance. It simply appears. As the green haze expands and the comet continues its escape, one question dominates the room. If this is what turns on first, what turns on next? The shock doesn't come from what can be seen. It comes from what suddenly can't be ignored. As the faint green glow spreads invisible light, another eye locks on from space, hunting for energy far beyond human vision. ESA's XMM Newton fixes its instruments on 3I Atlas for nearly 20 straight hours on December 3rd. The comet doesn't stay quiet. It answers back in X-rays, high-energy radiation, the kind that instantly upgrades a drifting ice body into a live physics problem. In that moment, the object stops being a distant curiosity and becomes an active source of energetic interaction, forcing scientists to lean forward instead of leaning back. X-rays from comets are not unheard of, but this detection lands differently. The timing is precise, the exposure window is rare, and the signal strength punches harder than expected. X-rays don't come from reflected sunlight. They erupt when fast solar wind particles slam into clouds of escaping gas. That means 3I Atlas isn't just glowing, it's colliding. The outflow from its nucleus is interacting violently with charged particles streaming from the sun, turning the comet's surroundings into a flashing, invisible battlefield. Suddenly, gases that hide in other wavelengths step into view. Hydrogen and nitrogen, hard to isolate with standard imaging, announce themselves through energetic reactions that can't be faked or smoothed away. The comet becomes chemically louder than it looks, speaking in a language only high-energy detectors can hear. This is where the mood shifts. Scientists aren't simply collecting images anymore. They're interrogating the object with radiation, probing how its gases behave under stress. The tail is no longer a passive plume. It's reacting, flaring, reshaping itself under a charged solar storm. Every X-ray photon carries information about what's escaping, how fast it's moving, and how deeply the sun's influence has reached. And once an interstellar object starts talking in X-rays, researchers know the rules change. New emissions can switch on without warning. New reactions can erupt as fresh material vents from within. The instruments stay trained, the clock keeps shrinking, and the next signal could arrive at any moment, opening a chapter no one is ready to close. The shock doesn't come from how 3I Atlas looks anymore, it comes from what it's made of. As fresh data streams in, scientists notice something immediately wrong. The chemical fingerprints do not line up with expectations. The ratios are off. Not slightly, significantly. The balance between carbon dioxide and water vapor, one of the most basic measurements for a comet, refuses to match anything routinely seen in the solar system. It's the kind of discrepancy that makes a room go quiet. At first, teams assume the problem must be technical. Instruments are recalibrated, software pipelines are checked. Independent groups reprocess the same signals using different methods, but the numbers don't settle. They persist. And when results stay strange after every safety check, the fear shifts from error to origin. Because if the data is real, then this object didn't just come from another star system, it was built under rules Earth's neighborhood never followed. As researchers dig deeper, more red flags surface. Spectral readings hint at unusual amounts of metals mixed into the dust, elements not normally dominant in comet comas at this stage. Grain structures appear inconsistent with the fluffy, ice-rich material typical of long-period comets. Instead, some of the dust behaves as if it formed in harsher, denser environments. That detail matters, because chemistry remembers where it was born. Different alone wouldn't alarm anyone. Interstellar objects are expected to be foreign, but this isn't random variation. The differences cluster together, pointing in the same unsettling direction. It suggests 3I Atlas didn't just travel far, it formed far away under conditions the solar system either never experienced or lost long ago. That implication forces scientists to confront a bigger question. How many ways can a comet exist? Each new burst of gas escaping from the surface becomes a sample from another stellar system released directly into our instruments. And every sample deepens the mystery instead of resolving it. Molecules appear in combinations that don't quite fit. Abundances tilt the wrong way. It's not dramatic enough to scream impossible, but it's wrong enough to resist classification. The comet keeps slipping through the cracks of existing models. That's where the real tension builds, because scientists rely on categories to understand behavior. And right now, 3I Atlas refuses to stay in one. It behaves like a comet, but not comfortably. It looks familiar, but chemically foreign. The fear isn't that it's something exotic or artificial. The fear is worse. That current comet science may be incomplete when applied beyond the sun's domain. Then comes the most unsettling possibility of all. Thermal models suggest the interior may only now be warming. The layers being sampled could be shallow surface-adjacent material processed by cosmic radiation over millions of years. If that's true, then what researchers are seeing might not be the comet's real composition yet. It could be the weathered shell, not the core. That idea sharpens the suspense. Because if deeper layers begin to vent later, after more heat penetrates inward, the chemistry could change again. New gases could appear, ratios could shift further, entire assumptions could break. And timing becomes critical, because every day the comet moves farther away, dimmer, harder to study. So the unease settles into a single, heavy question hanging over every observatory watching 3 3I Atlas. What's still buried inside? And if the most revealing material hasn't escaped yet, then the next phase may not clarify the mystery. It may explode it wide open, just as the comet starts slipping beyond reach. The shock hits instantly. Not in a sealed laboratory or behind closed doors, but out in the open, broadcast live. Gemini North locks onto 3I Atlas during a real-time observing event, and the comet does not behave like a quiet, distant object. It moves fast, precise, and unnervingly clear, while the background stars stretch into rainbow streaks behind it. The effect looks less like astronomy and more like pursuit, as if something is being chased across the sky instead of passively observed. Students, researchers, and viewers watch the same frames arrive at the same time. There is no buffer, no delay, no chance to soften the moment with interpretation. The data appears raw and unfiltered, forcing instant reactions. The comet stays sharp, almost defiant, while everything else smears and bends around its speed. It becomes impossible to ignore how fast it is moving and how little time there is to understand it. The tension spikes because the behavior is unfolding live. This is not a polished image released weeks later with careful wording. This is an interstellar object actively changing while people are watching the telescope track it. Every second feels loaded because a new flare, a sudden brightening, or a shift in the coma could happen without warning, and if it does, it might never repeat. The realization sinks in hard. This is a one-time visitor. 3I Atlas is tearing through the inner solar system at roughly 137,000 miles per hour. There will be no return orbit, no second chance, no follow-up mission years from now. Every missed night is lost data forever. Every unexplained signal becomes permanent mystery. Behind the scenes, scientists scramble. Space-based instruments are redirected. Observation schedules tighten. Hubble, Webb, and other assets are coordinated like an emergency response, not a routine study. The goal is no longer perfection, it's capture. Get the data now, even if it's incomplete, because waiting risks getting nothing at all. To the public, it looks like a thrilling live demonstration. To researchers, it feels like a countdown. Once the comet fades, angles worsen, distances grow, and signals weaken. If something critical activates late, if deeper layers suddenly vent, if a new emission turns on, it may happen when the comet is already slipping beyond reach. That shared tension hangs in the air. Everyone is watching the same moving target, hoping it reveals one last clue before it escapes. And as the frames keep coming in, one unsettling thought starts to form quietly in the background. What if this live moment isn't the reveal at all, but only the warning that something bigger is about to begin? The danger is already in motion. Scientists know they cannot stop it, slow it, or call it back. 3I Atlas is screaming through the solar system at a speed the sun cannot tame, fast enough to ignore gravity's grasp and vanish forever once it passes. There will be no second approach, no return window, no chance to correct mistakes. Every strange signal arriving now carries a crushing weight, because if it is missed, it is lost for all time. That reality turns the comet's behavior into a countdown threat. Heat from the sun does not always trigger an instant response. In many comets, warmth seeps inward slowly, layer by layer, until it reaches a volatile pocket buried deep inside. When that happens, the reaction can be sudden and violent, an abrupt surge of gas, a rapid brightening, a chemical flare that switches on without warning. For 3I Atlas, that delay is terrifying. The most dramatic reaction may not happen near the sun, when telescopes are best positioned, but later, when the object is already fleeing, smaller, dimmer, and harder to track. This is why the current green glow and the unexpected X-ray emissions are not calming signals. To researchers, they look like early tremors before a larger release. The comet is already talking in wavelengths it should barely whisper in, suggesting that solar heat has begun unlocking deeper chemistry. If those layers continue to warm, the next phase could arrive suddenly, rewriting what scientists think they know without giving them time to prepare. Teams across space agencies are bracing for abrupt shifts. They are watching for gases that should not appear yet, brightness jumps that defy prediction, or behaviors that refuse to match known comet models. Every observation is treated like a potential last warning. And because this object came from another star system, any anomaly is more than a curiosity. It is a message from an alien chemical environment, a rare sample of how planets and comets form elsewhere in the galaxy. That fear has triggered something close to scientific emergency mode. NASA and ESA are stacking every available eye on the target. Hubble locks onto fine detail. Webb hunts for hidden molecules in infrared. Mars Reconnaissance Orbiter, Lucy and Psyche contribute unique angles and timing. This is not routine scheduling. It is a coordinated race against geometry, distance, and time. Each hour matters. Each missed observation closes a door that will never reopen. The brutal truth is simple. If the comet erupts after the best viewing window slips away, the evidence will fade into noise. A surge that happens too late could be detected only as a hint, a ghost of data with no clarity, no confirmation. Scientists know this, and it sharpens every decision. They are not asking what the object is anymore. That question can wait. The real fear is timing. Because the next phase may already be forming beneath the surface, warming silently as the comet races outward. And if it breaks free at the wrong moment, the most important clues may reveal themselves just as 3I Atlas becomes hardest to see, setting the stage for a discovery that arrives too late to fully understand, and forcing the next chapter to begin under even darker uncertainty. The signal doesn't collapse the theory, that's the problem. As the latest data pours in, officials repeat the same conclusion with careful confidence. 3I Atlas is still a comet. Its motion fits, its shape fits, its behavior on paper fits. And yet, the room never relaxes. Because nothing about the details feels settled. Online speculation surges, racing ahead of the science, trying to force the object into stranger categories. But researchers push back, not defensively, but uneasily. They don't need fantasies to feel disturbed. The discomfort is already inside the data. From the outside, 3I Atlas behaves like a comet should. It grows a coma. It vents gas. It reacts to solar heat. But when scientists zoom in on how it does these things, the familiarity starts to crack. The emissions don't line up cleanly. The ratios feel off. The chemistry carries signatures that don't match the solar system's usual recipe. They describe it carefully, familiar but foreign. A known object type, marked with fingerprints from another star system. The green glow confirms fresh gases are turning on, as expected. The X-rays confirm the solar wind is slamming into the outflow, lighting up interactions invisible to normal cameras. But then the deeper readings arrive, and the tension spikes again. Carbon dioxide and water don't behave like they usually do. Trace elements appear where they shouldn't be this prominent. Dust signatures hint at a formation history shaped under conditions Earth's neighborhood never shared. Each new data set does something unsettling. It reassures scientists they're looking at a comet and quietly expands the list of reasons this comet doesn't belong here. That contradiction is what keeps the pressure high. There's no dramatic break that ends the mystery, no single clue that lets everyone breathe out. Instead, the evidence stacks sideways, building a structure that looks stable, until you notice how strange the angles are. And the timing makes it worse. Heating effects don't always happen immediately. Energy creeps inward. Layers respond late. Pockets sealed for billions of years can suddenly vent long after the closest pass to the sun. That means the most revealing material may still be buried, waiting for a delayed trigger no one can predict. So scientists widen the net. They track 3Y Atlas across visible light, infrared, ultraviolet, and X-rays, watching for even the smallest shift. A new emission line, a sudden brightening, a chemical spike that forces a rethink. Every instrument stays locked on, not because they expect chaos, but because they fear missing it. Because the object is already leaving. Every hour, it moves farther away. Every day, the signal weakens, the window narrows, and the most dangerous possibility hangs in the background. The next major reveal could arrive just as observation becomes hardest. That's what makes the situation quietly terrifying. Not what the comet is, but when it might finally speak most clearly. The chase continues under a shrinking deadline. The data clock is ticking, and the visitor will not turn back to finish the story. Because in the next phase, the question may no longer be what 3I Atlas is, but whether scientists will still be close enough when it decides to show it.